Before time, before space, there was nothing. An endless, silent darkness. Then, in an instant, a single point of light erupted, shattering the void. This was the Big Bang. The universe was born in a flash of unimaginable energy, expanding faster than light itself. From this cosmic explosion, time began to flow, and the fabric of space stretched outward, creating the vast canvas upon which our story would unfold. For millions of years, the young universe was a hot, dense soup of particles. But as it expanded and cooled, gravity began to pull matter together. Clouds of hydrogen and helium gas condensed, and under immense pressure, the first stars ignited. These were not like the stars we see today. They were giants, hundreds of times more massive than our sun, burning fiercely and living short, violent lives. Inside their fiery cores, a cosmic alchemy took place. Lighter elements were forged into heavier ones: carbon, oxygen, iron, the very building blocks of our world. These massive stars burned through their fuel in just a few million years. Then, they died in the most spectacular way imaginable: a supernova explosion. In a blinding flash, the star would blast its newly forged elements out into the cosmos. These stellar remnants formed breathtakingly beautiful nebulas, vast clouds of glowing gas and shimmering dust. For generations, stars were born, lived, and died, seeding the universe with the raw materials needed for what was to come. Our galaxy, the Milky Way, became a rich repository of this cosmic dust. About 4.6 billion years ago, in a quiet corner of the Milky Way, a vast, cold cloud of gas and dust began to collapse under its own gravity. Perhaps a nearby supernova sent a shockwave through it, triggering its fall. As the cloud spun faster and faster, it flattened into a massive, rotating disk, a protoplanetary disk. At its center, pressure and temperature soared, until nuclear fusion ignited. A new star was born, our sun. Its brilliant light illuminated the swirling debris around it, a cosmic nursery filled with countless grains of dust and ice. Within this spinning disk, the seeds of planets began to form. Tiny particles of dust, drawn together by static electricity, started to stick. Clumps grew into pebbles, pebbles into rocks, and rocks into massive boulders miles across. This process, called accretion, was a chaotic cosmic ballet. Countless objects collided, some shattering, others merging and growing ever larger. Among them was a young, growing world, the protoheart. It swept through its orbit, gobbling up debris and rapidly increasing in size. In its early days, Earth was a hellish world, completely unrecognizable. The constant bombardment from space rocks generated so much heat that its entire surface was a global ocean of molten magma. It was a glowing ball of liquid rock. During this molten phase, a great separation occurred. Heavier elements, like iron and nickel, sank through the liquid rock, drawn by gravity toward the center of the planet. They accumulated to form Earth's dense, metallic core. Lighter materials floated to the top, eventually cooling to form the crust and mantle. Earth was beginning to take shape. But the most dramatic event in Earth's youth was yet to come. A rogue planet, about the size of Mars, which scientists have named Theia, was on a collision course with our young world. The impact was cataclysmic. Theia slammed into Earth at an incredible speed, tilting our planet on its axis and vaporizing huge portions of both bodies. A colossal plume of molten rock and debris was blasted into orbit around Earth. Gravity went to work again, pulling this fiery ring of debris together. Over thousands of years, it coalesced, cooled, and solidified to form a new celestial body, our moon. After this violent birth, Earth was a scarred and fiery planet, with its new companion, the moon, orbiting much closer than it does today. But slowly, over hundreds of millions of years, the planet began to cool. The molten surface hardened into a dark, solid crust of volcanic rock. As the temperature dropped, water vapor that had been trapped in the atmosphere began to condense, and then it started to rain. Not for days or weeks, but for millions of years. A relentless, planet-wide deluge poured down onto the hot crust, creating vast clouds of steam. This great rain filled the basins and craters, and the first oceans began to form. Earth was transforming from a world of fire to a world of water. Beneath the surface, our planet's future was being secured. The sinking of heavy metals had created a solid inner core and a liquid outer core of iron and nickel. As the planet spins, the movement of this liquid metal generates powerful electrical currents. This process, known as a dynamo, turned our planet into a giant magnet, creating a powerful magnetic field that extends far out into space. This invisible shield, the magnetosphere, is our planet's guardian. It deflects the constant stream of charged particles from the sun, the solar wind, protecting our fragile atmosphere from being stripped away and lost to space. Without it, life on Earth would be impossible. With the oceans in place and a protective magnetic shield, the stage was set for life's debut. But how did it begin? The early Earth was a dynamic chemical laboratory. Volcanic islands dotted the oceans, their shores lined with hot, manure-rich pools. In the deep sea, far from the sun's light, hydrothermal vents gushed superheated water, thick with chemicals from Earth's interior. In these environments, whether in sun-drenched pools or dark ocean depths, as simple molecules dissolved in water were energized by heat and lightning. They reacted, combined, and formed more complex structures like amino acids and nucleotides, the fundamental components of life. Somehow, among this chemical chaos, a miracle occurred. Fatty molecules, kajet lipids, spontaneously formed tiny bubbles, or sacs de first. These membranes enclosed a watery interior, creating a stable environment separate from the outside world. Inside these bubbles, other molecules began to carry information and replicate themselves, perhaps using RNA. It wasn't life yet, but it was close. The systems that were better at replicating and protecting themselves survived and multiplied, passing on their traits. Natural selection had begun, operating on a microscopic, chemical level. The journey from non-living chemistry to living biology had started. For hundreds of millions of years, these simple life forms thrived in the oceans. Then, a revolutionary innovation changed everything. Some of these early cells, known as cyanobacteria, evolved a remarkable new ability: photosynthesis. They learned to harness the energy of sunlight to create their own food. As a byproduct of this process, they released a waste gas, oxygen. At first, this oxygen was absorbed by iron in the oceans, forming vast rust deposits. But eventually, the oceans became saturated, and oxygen began to flood into the atmosphere. For the early life forms, this oxygen was a deadly poison, leading to the planet's first mass extinction. But for others, it was an opportunity. Oxygen transformed our planet. It created the ozone layer, which shielded the surface from harmful ultraviolet radiation, and it provided a powerful new source of energy for life. Cells evolved to not just tolerate oxygen, but to use it to fuel their metabolism. This energy revolution allowed for a new level of complexity. Single cells began to cooperate, forming colonies and eventually multicellular organisms. This led to an explosion of diversity in the oceans. Animals appeared with specialized tissues and organs. Predation became a major evolutionary driver, leading to an arms race of shells, claws, and something truly game-changing: the first eyes. The world was now a place of hunters and hunted. For billions of years, life was confined to the water. The land was a barren, rocky desert. But life is relentless. In the shallow coastal waters, some fish evolved fins strong enough to prop themselves up on the muddy bottom. Over millions of years, these fins slowly transformed into limbs. Air-breathing sacs evolved into lungs. Gradually, tentatively, the first four-legged animals, amphibians, crawled out of the water and took their first steps onto solid ground. It was a monumental leap. They were followed by plants, insects, and eventually reptiles, who fully severed their ties to the water. A new, green and living world began to spread across the continents. From a violent cosmic explosion to a cloud of dust, from a molten ball of rock to a world of water and life. The journey of our planet is a story of chance, chaos, and incredible transformation. A 4.5 billion year epic of fire and ice, collision and creation. What began as scattered dust in a forgotten corner of the galaxy has become a living, breathing planet, teeming with an astonishing diversity of life. We are the inheritors of this incredible legacy, a conscious part of the universe looking back at itself, still trying to unravel the mystery of how it all began. The story of Earth is our story. Thank you for watching. Don't forget to like and subscribe for more journeys through space and time.